A stopwatch is put into a centrifuge and sped up to 0.85 C, which, by the way, this thing is in a tremendous, it's accelerating tremendously, right? So another way to explain why it's running slower, why only 31.6 seconds elapse when 60 seconds elapse in the lab, is that it's like the acceleration, the centrifugal acceleration acts like gravity, right? Acceleration slow clocks down, which is kind of cool, right? All right. But anyway, let's go to this, right? And of course, the great mystery here is that, of course, we know that the clock is going to run slower, right? The moving clock slower. Okay, the stationary clock it runs faster, right? Runs at a normal speed, right? So if 60 seconds elapses on the stationary clock, right, the clock that's moving slower is going to be ticking slower. So in our 60 seconds, it's going to show less time, right? So the hands move not as far, right? So forget trying to take that formula and stuff the numbers in and what's proper time, what's not proper time. Just take that factor, the square root of 1 minus 0.85 squared, right? That thing is going to be less than 1, and so we just multiply the 60 by that to make it smaller. We know that less time is going to elapse. Otherwise, you'll go mad trying to figure out the 1 minus 0.85. So in other words, just go through this thinking process, right? The moving clock runs slower, so the hands move not as far. Stationary clock runs at normal speed. All right, here we go. I get 31.606 seconds. There we go. So just to understand, this is not, we're not asking how long does that clock take to read 60 seconds. We're asking the question, if we see 60 seconds go by in a stationary frame of reference, how much time goes by on that clock, which is, of course, less time because it's moving slower, right? 31.6 is less. 60 because the moving clock ticked slower. Hopefully that won't tick you off. So just reason it through. Go. You know in your heart of hearts what it has to be, and then go from there.